So we're talking about pair programming. I'm not entirely sure what I want the outcome of this to be just yet. So to help me figure that out, I would like each and every one of you to spend 2 minutes writing me your questions about the idea of pair programming. Go. Slack it over to me when you're done. These are great. Keep them coming. Okay, if you got anything else, slack it to me now. Elsewise, this is a pretty dang good list. Let's take a look at it. Okay, so let's read through these. Cool. So let's talk about some history. Pair programming is one of the techniques from a discipline called XP, or extreme programming. Sounds like a Mountain Dew commercial. Well, the thing that's extreme about it is that in the mid 90s, there's a group of devs who were trying to elevate the craft of programming to like a real engineering discipline. And so they said, all right, well, our code is better when we work in pairs. So why don't we do that all the time? Our code is better when we write the tests before we write the code. So why aren't we doing that all the time? So they took all these good ideas and best practices and took them to their logical extreme. And so the package of these things is referred to as extreme programming. I will say that XP is kind of rare, not for any good reason. Like it's very difficult. It's demanding. It's like the engineering side of writing code. And as such, there's a lot of people who go, no, thank you. I'll just write shitty software. You get paid the same amount. So the most interesting question on here, I think, is what are some disadvantages of pair coding? The traditional answer to this question is you have two people doing one job, so it takes twice as long. No, 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 no. That is straight up not true. But that's what a lot of people assume, even having done it before, that the issue with pairing is. So let's take a look at programming a little bit more holistically, or like the active writing software. So you have a couple different things that are part of that. We need to.
I have a quick question.
Yeah.
So would you say that Flatiron embodies like the test-driven development?
No, not at all.
Okay.
The Learn Labs are kind of like that, except you aren't writing the tests. So I don't think that counts. I think you have to write the tests for it to really.
Yeah, that's what I was reading. I read a little bit about it, and I was like, yeah, but okay.
But yeah, if you can imagine those labs where you were writing the tests one at a time and then making those pass, that's TDD. We don't teach TDD at Flatiron, and I think that's actually kind of a good thing. Reason why is that TDD is all about prediction. I predict that this thing will happen when I do this. And then when that's obviously not true because no code exists, you write just enough code to make the thing true. So to do that effectively, you need to be a good predictor. And it's very difficult to predict the outcome of programming stuff if you haven't written any fucking code before. So I would say that like by the end of the program, you're in a pretty good place to start experimenting with TDD.
Okay.
It has been my experience over the last 5 years that it's more frustrating than anything to do that too early. So that's why we don't do it. That said, if I haven't convinced you, because TDD really is like the shit, then I believe we've got a pretty good collection of videos, at least some, on the TDD process. There we go. So these two in particular, I think would be very instructive if you're interested. Both of these are interviewing code challenges that I solved using TDD. So they're just demos, but if you want to see what TD is supposed to look like, those are two pretty good examples of it.
Okay, cool.
Cool. So the things that we need to do to make a feature. We need to form up problem statements. Come on, it's the end of the day for everybody. We need to consider solutions. Hey, weird, this is sort of starting to look like Polya. We need to write code. In a production environment, we also have to write tests. You can write them before, you can write them after, but you got to write them. So, I mean, this is our 4-step process right here, effectively. But we also need to document it. Part of writing code that's really easy to forget is we need to improve it. Getting code to like make the test go green, that's usually actually not that hard. Keeping it green while making it better, that's the craft. And so if you're skipping that, you're just leaving a lot of half-finished work around. We need to document it. We need to deploy it. There might be some integration work that needs to be done. Okay, so all of these things are part of like making software, and one of them isn't really any more important than the rest of it. Like if you solved the wrong problem, it doesn't matter that your solution was mega efficient. If your tests, if you didn't write your tests very well, then okay, it might work in this one circumstance. As soon as something slightly out of the ordinary happens, now it doesn't work anymore. That kind of sucks. If we don't have documentation for it, how's anybody going to use it? Like that, like think about when you've had to read documentation for Ruby or something like that. If the documentation isn't there, you assume the thing doesn't exist, so you may as well not have written it. So all of these things are all part of it. The like, oh, well, it takes twice as long if you're pairing. What that comes from is assuming that programming is typing. And that is absolutely false. If that were true, then yeah, it takes twice as long. But think about how much on this list is thinking work, not typing work. Even like when we're writing the code, we're essentially transcribing a solution that we figured out. That's thinking work. And this gets very synergistic very quickly. You may have had a great idea, a great solution for something, and your pair figures out a problem with it, or has an even better idea. Or what happens way more often, they take your good idea and improve it, and that gives you an idea for an even better solution. That's way more effective than trying to have that entire conversation in your head. That's one reason that this is more efficient than it might seem on the surface, 2 people doing one job. The other reason has to do with some of our educational psychology stuff, believe it or not. So your brain has 2 modes. You've probably heard me refer to them before as rich mode and linear mode. So, and then here's your, I'm a really good illustrator. Here's your brain. So you have these 2 modes. You can think of them kind of like a switch. Only one of them can be on at once. Your linear mode is like, call that like systematic problem solving. When you're like writing out code, you're in linear mode. If linear mode is also where a lot of like language is. It's not a bad mode. And also like not coincidentally, these start with L and R. Left and right brain isn't a thing. That's kind of like learning styles where like it's a complete misunderstanding of how brains work. But you do have 2 distinctly different processing modes, and those are either or, but everybody uses both of them like at different times. So your rich mode, by contrast, is good at lateral thinking. It's good at recall. So like you can think of your rich mode as like the most powerful search engine ever imagined. This is every experience you've ever had. This is wild and crazy ideas. And this thing is a like problem solving machine. However, it lacks language and you can't access it directly. You can't go rich brain mode on, go. You can do that with your linear mode. Can't do that with your rich mode. What you can do is you can invite your rich mode to turn on. And you do that by boring your linear brain. So this is what meditation does. This is what walking labyrinths does. This is what deep breathing does. Is you give your linear brain something that's just too easy for it. And it bores it and invites your rich brain to turn on. Another way that this comes into effect is that when you're stuck on a problem, can't solve it, bang your head against the wall. And then you walk away for a little bit and you come back and the answer's right there. There's two things happening. One is you've changed context. I have this context that I'm looking at this problem in. I walk away, I have a different context, and I come back and I need to reestablish this context. In the process of doing that, you'll usually find that the reason that no matter how much I slam against this problem, I can't solve it, is you're looking the wrong way. And as soon as you have to reestablish that context, now you can see it for what it really is. So that's the first thing that happens. Second thing is when you walk away from it, let's say you're literally going for a walk, you're inviting your rich brain to turn on. And your rich brain's way better at solving programming problems, especially hard ones, than your linear brain is. So you'll walk around, you'll take a shower, you'll do something else, you'll be eating, you go, oh, I've got it. That's your rich brain figuring that out. And then you just need to translate it into code. Cool. So the reason I told you all that is when we're pairing, it's creating an opportunity for the person typing to be in linear mode and the person navigating to be in rich mode. It's like having a super brain working on a problem. So these are like all the advantages of it. And this is why the like, doesn't it take twice as long? Like why that's complete bullshit. There are downsides to it though. The biggest one is that it is exhausting because like you are talking with another human being all day. And a lot of you are probably like, but I got out of customer service, so I wouldn't have to fucking do that anymore. Like it's at least like presumably somebody you like and it's a teammate, but that doesn't mean that it's not draining. And so if you're going to effectively pair, you need to be way on it about taking breaks, like disconnecting, giving each other space as well. But in like normal XP tradition, you don't even necessarily get your own computer. You have a shared workstation that you're writing code at. Doesn't mean you need to do that 8 hours a day, but if you are contributing code, you are not to do it without another person. That's the like extreme application of XP. So if you're gonna do that effectively, you guys gotta be way on it about giving each other some breathing room too. Cool. Okay, I'm gonna pause there, ask you some questions about what we just talked about.
So it sounds like it's pretty industry standard for pair coding in most companies.
No, unfortunately not. It's one of those things like testing or test-driven development that it's industry standard to say you wish you were doing. And then go, sorry, yeah, we're just out of time. We're in a real big crunch right now. So we need to be full steam ahead. Now, we've already established that it's not faster to write code this way, especially given the amount of like brain involved with all of this. I think that in the long run, you get way more code done way quicker with something like pairing than you would working on your own. People will give lip service to this, but it is industry standard to not do that, actually. Because some accountant goes like, hey, you got two people doing one job. Oops. Oh, one more reason why it doesn't take twice as long when you're pairing is you write better code. So why does that make things faster? Because you don't need to go back and fucking rework it like every other day because you did such a bad job with it. Or it worked right up until you added something new and then that thing fell apart and you had to go back and fix it. When you're working with somebody else, that happens way less often. It's like having a code review in real time. Another thing that I notice is that when I'm like typing, I make all kinds of like dopey little syntax errors. Like I was writing some Java this morning. Java has required semicolons. They're optional in JavaScript. I mostly write JavaScript. And so I was doing them all over the place. And I was like, why the fuck won't this work? And immediately my pair could go like, semicolons. Like, oh, yeah. I can't see that. I'm forcing this other context on it. Other person has a different context. They can catch that stuff. So I would have caught it, but like not right away. And every little thing in programming like that you just don't catch right away, but the other person can, that's saved time. So no, tragically, not industry standard. Should be.
How often do the two people usually switch roles, like from typing to thinking?
Super good question. So there's a couple questions about that on the list also. You can do this a couple different ways. You could do it on a timer. So I would say like, if you're doing it on a timer, something like 15 minutes, yeah, that would feel okay to me. Could be a little bit longer. Could be like, depending on how fluid your environment is, like if there isn't a lot of cost to switching, I could be talked into doing it every 5 minutes, 10 minutes. If it was every half hour, I could probably live with that too. But if you're doing it on a timer, I'd probably look at that kind of range. You could also do it by story. So a story is a feature. I'm going to build this feature. I'm the driver, you're the navigator. Then on this next feature, we'll switch. I've also heard of teams doing this like by day. That sounds stupid to me. It sounds like you're just wearing out one person and then wearing out the next person. So yeah, I would err on the quicker side.
So you can train your rich response to respond quicker if you create a pattern of like meditation or walking or something like that, right?
Mm-hmm.
Okay, I need to do that.
Correct. Yes. So yeah, the meditation kind of stuff, it sounds very woo. It's not. There's like very good brain science behind this. Cool. Let's look at some of these questions. Is it better for one person to be the driver and the other to be the passenger, or both code at the same time in your own computers? So the pairing discipline specifically refers to there is like one environment happening. So this is the code. Now, what happens like to connect both of these people to this environment? This varies dramatically. So, and maybe the worst case scenario, it's a laptop and you're both cheek to cheek, as somebody said, and you pass it back and forth. That's pairing. I would not super recommend doing it that way. Another way you could do it is you both have your own laptops. And When you switch, you push your code up to GitHub, other person pulls it down, and then we're right back in action. That's fine. I think that's what most people at Flatiron, even in like the good old days, did. Moving on from that, there's dedicated pair workstations. So this is each person has a keyboard, each person has a mouse, but they are hooked up to one workstation and one monitor. So both people can control the screen at any time, but they're effectively working on the same computer. And then there's some like more modern options, like VS Code has like a pairing thing built in where you can essentially like remote into somebody's computer and then both of you have control over it. Zoom has that as a feature too. And even like old command line Kyle, we got a way to do that too, using like command line tools that effectively works the same way. I will say that I am not as fond of those. They're cool, they're magical, they're also fucking laggy. And so I find it excruciating to type on those because everything is like half a second behind when you type. So I just make errors all over the place when I use them. But those, for like teams that pair, those feel like they're way more common right now than the other ones. Pair programming seems to be at its best when both people are talking out the same problem, not just saying, I build this, you do that, see you in 2 hours. Yes, well, let's meet back up in a couple hours and like compare solutions or merge our code. That's not pairing. In fact, that's a recipe for just bad software. It's probably going to be when you guys work on your first group project, which will be next week. It's good. That's going to be your natural instinct, is to chop up the work, assign some stuff out, and then merge it all together on Thursday night, book report style. Good luck with that. I would not recommend doing it. It will not work. You will have some not working software by the end of that. So I want to bookmark this like effective methods thing. So I'm going to pull that out. Is it possible to code on one program at the same time on different computers? Yeah, so that's what we're talking about with different approaches to the workstation. You got some options there. Overall, don't overthink it. Like what has the lowest friction in it for you right now? What do you have available? Just do that. Just start writing code. I'm afraid I'll overwrite things, get confused about which code is newer, when to merge. So some of that is just developing more confidence with Git. And Git actually has very good tools for like, this one is newer and it was made by this person, but this one was older, but it's longer and it's made by this person. Which one do you want? There's pretty good tools for that. I wouldn't worry too much about them right now. You'll get a lot of experience in your first project with not stepping on each other's toes too much with shared code. Don't worry about it too much. We talked about technologies a little bit. Should one person just take the lead? That I would not recommend. Have a schedule, have a system. Feel like, even if it's like, all right, I'm going to go first and I'm going to go until I'm tired and then you take over. Like, just have some kind of agreement up front, so you both kind of know what the story is. How many people is too many to work on coding in a group? So this is extreme programming. So we've talked about this with pairs, but can you pair with more than one person? Yes, and there's a specific name for that. That is called mobbing. Why am I doing this? I have a pen right here. Mob programming is pairing in a group of more than 2 people. So maybe the single best programming experience of my life was like towards the end of my time at my last job. We were having a lot of issues with integration and kind of feeling like a team. We all worked on our separate stuff. So we tried mobbing. it was 6 of us sitting on a couch in front of a giant TV, passing around a wireless keyboard and mouse. And it rocked. We got more done in like the 2 weeks that we did that and like the year that I'd been there. And it was so cool because you could just observe and you could start seeing some patterns. You could kind of get an inkling of an idea. You maybe scribble on paper a little bit. You go, oh, hang on, I got a cool idea. Can I try something real quick? And then somebody hands you the keyboard and mouse and you try something and you go, okay, well, this sort of works. And somebody goes, oh shit, I got an idea. Hand it over. That was like, it was such a magical vibe working on a team like that. And relevant. I just saw today this get posted. Jeff Langer, who is the guy who more or less invented mob programming, old school ex-peer, who's going to be talking about this on August 18th. So if you'd like to learn more about mobbing, I would highly recommend going to that. But yeah, since we've already like figured out that programming isn't typing on a computer, it's mostly up here, then it shouldn't be a surprise that it's not mega inefficient to have the entire team working on one computer at a time. All right, back to questions. Talked about that. Talked about that. So like brainstorming together, showing your answers to code problem, comparing, contrasting. I'd recommend doing that as little as possible. Which isn't to say it's like against the rules. You could do something like, all right, let's both work on solutions to this problem, the same problem, for 5 minutes, and then let's compare our approaches. The reason you would do that is because like the mental overhead of being in a conversation all the time is like fucking with your ability to problem solve, and you need a sec to just sit in silence and look at something for a little bit. I would suggest that a probably more healthy activity is to do that as a pair. So rather than like split off, it's like, okay, can we just be quiet for a second and stare at this? That's a reasonable thing to ask of your pair. Talked about that. How is pair programming used in the interview process? That's a great question. All the time. Super common. Probably more common than actually using it to write code is pairing in interviews. And there's a couple reasons for this. One is, let's say you're working with like their actual code. Well, they're probably not going to send it to you. But you can see it and you can work on it together like through their terminal. So that's one reason you do it. Second reason you do it is if the challenge is in a language you don't know. So for example, I did a challenge once in Java. I'm not a Java dev. Now, I've told you guys over and over again that there's not loops and other loops. There's not ifs and there's Java ifs and Ruby ifs and Python. It's all the same stuff. Programming isn't that different language to language. So I can figure out my way through some stuff, especially if I have a driver who can write out the syntax. So if I can say, all right, let's loop through this, and then for every one of these, can we do this? And if this is the case, do that. Figure out what that syntax is in Java. Now, I get to be in rich problem-solving brain that other person can translate into whatever language we're doing. So those two reasons are why you'll see that a ton. A third reason is you get a really good sense of what someone's like to collaborate with. Pair with them for an hour. Go, cool. would I want to do this all week, every week? And if not, that's a pretty good reason to not have that person on the team. And then, yeah, don't divide the labor. Like you have different roles as a driver and a navigator, but you're doing the same work together. You are one team. Okay, so that's some context on extreme programming. Hit me with some more questions.
So when it gets time to do our project, is it more expected that we're just going to work on it together all the time? Or if like someone has some time on their own, is it okay to maybe try to write some code?
I would recommend for your projects to pair the entire time. Not a rule. You can like break off here and there to play with some stuff. What you don't want to do, and boy does this happen, is like, all right, good day of coding, everybody. And then like you show up the next morning and someone's like, yeah, I just stayed up all night and wrote a whole bunch of shit. Like, do not be that person. You probably got that habit from like school book reports and like group projects and stuff. They're like, yeah, but I really need this fucking grade. So how about I just do it and like, we'll just call that good. You don't get graded on these things. So like, if your project sucks, if your project sucked and you worked together, I feel great about that. If your project rocked, but one of you basically did the entire thing, I'm kind of disappointed in both of you. So I would recommend like 90% plus of your time in your group project should be like on a call together.
Whenever you mentioned giving your partner space, what exactly did you mean by that?
Sure. So like it's socially exhausting to like talk one-on-one with another human being a lot. So being cognizant of that and just taking a lot of breaks. So I did some pairing a couple of weeks ago where like it was a 3-hour long session and we did 2 breaks. Basically like at every hour, I was like, all right, take 5, take 10, go for a walk. I'll see you in a sec. That just gives you like a little bit of time to like reclaim some of your personal energy and just not fucking talk for a little bit. Also helpful as an educator. Other questions? Cool. So here's what I want to do. We got 15 minutes. I want you to practice this. And I want you to practice it with our reverse a string problem. I'm going to give you a solution to it, except I'm going to give it to you in JavaScript. So you can't just straight up copy it. But I want you to focus less on the problem solving part of this and more about the communication. Let's see. Oh, actually, shoot, instead of writing this, I would just show you a Java one and make you reverse engineer that one. Yeah. And let's see, no, Python. Python reverse a string. Oh shoot, that one's too hard. That one's too hard too. All right, do the JS one. Okay, cool. So I'm going to put you guys into groups, and I want you to switch every 2 minutes. Every 2 minutes, you should switch driver and navigator, and you should try to reverse a string. If you guys want to do it, like, and actually try to solve the problem, God bless. If you want to do it and see if you can just translate this from JavaScript to Ruby, that's fine. If you get this knocked out really quick, there's like 10 different ways to solve this problem. See if you can figure out a different one together. But really focus on this driver navigator thing. Driver is the person typing out the code. Both of you can come up with ideas, but primarily the navigator is like, it's the decider. Whatever the navigator says goes, just in the name of expediency. Questions about what we're doing? All right, I'm going to paste this JS code in a comment for our, where we got the Zoom link. There you go. And I'm going to do breakout rooms and assign 11 participants into 5 rooms. All right, one of you is going to get to mob. Oh no, I'm one of them. I see. I'm going to move to breakout room 2. All right, cool. There's your rooms. Switch every 2 minutes. See if you can implement this in Ruby.